So, good morning, folks. I hope you can hear me, and welcome to our webinar about function safety according ISO 26222 and SOTIF, the other safety standard. So, before we go to the main content, so maybe a few words in advance how that webinar is organized. So, first of all, if you feel my voice is a bit sounding like that I'm at home in the bathroom or something like that. So sorry for that. That's the best we can bring up today. So it's, of course, you know, all channels are heavily loaded, so could be that we have some issues there. So, but I hope you can still understand what I'm saying. That is the most important thing. Yeah, how is it organized? So first of all, introducing myself. My name is Arnulf Braatz. I'm leading the team of safety security expert at Vector Consulting Services. So I will guide you through this webinar next, I don't know, 55 minutes. And with me, somehow virtually, is Andreas Horn, my colleague. He's responsible for, as usual, for the question and answers, which may upcoming during this webinar. So that's maybe an important message for you if you're not so much used to these webinars. So if you have technical issues, I don't know, if you can't see anything, you can't hear anything, whatever, please use the chat window to talk to our host. He will help you as far as she can. And that's one thing you can do. I hope you have no trouble, of course. And the other thing is, of course, if you have questions in the course of the webinar concerning the content of safety, so then, of course, you have to answer someone else, and that is Andreas. He is waiting for you in the Q&A window in your WebEx client. So there you can place your questions. He will answer them as fast as he can. Typically, in the middle of the webinar, the number of questions is heavily increasing. So that means he has to answer a lot of questions in parallel. That could mean that he takes some time. So be patient and wait for his answer. And of course, even after this webinar, if you stay in the chat, as long as you are there, we will answer your questions directly. We will not leave the virtual webinar until we have answered every question for everybody who is still in. If you have no time to stay, of course, we will also send you answers to your questions after the webinar in the next few days, somehow offline. So finally, every question has been answered, has been asked, should be answered at least a few days after this webinar. Okay, so far so good. I hope everything is good on your side. So we can start with the main content. So before we do safety, maybe a few words to Vector, just to let you know who we are, and to Vector Consulting Services. So I think most of you, otherwise you would not be here in this webinar, you are somehow addicted to the automobile industry, so you know Vector from the tool side, various tools for configuration of ECUs and communication between ECUs in the area of CAN, Ethernet, and LIN and FlexRay buses. So that is well known. So more or less 3,000 employees are meanwhile working for Vector worldwide. That is a big part of Vector. So Andreas and me, we are coming from Vector Consulting Services, which is a 100% owned company, a consulting company from Vector. We are located in Stuttgart mainly, and even in Munich and also in Seoul. But we are not in all the places you see here on the map. But we do our business across the globe in terms of supporting companies concerning improvement of their development processes and organizations and methods. And functional safety is, of course, one very important driver for that, because that is driven by the standard ISO 26222, as you maybe know already. And that is the same one in each part of the world. So if you are an expert in that area, you are highly demanded in many places. So that is our business as consultants. And yeah, and of course, what we present today is somehow an essence of what we have learned in the last few years about functional safety since 2011, since the standard is out. Okay, yeah, maybe one thing concerning what is the situation of the automobile industry currently. Each year we do a kind of survey. So this is the latest result of a survey we did end of last year, beginning of this year, a bit before Corona, to be honest. But that was the kind of summary. We found out or figured out how the companies in automobile industry are thinking about challenges, short-term and long-term challenges. So of course, the most important challenge, somehow the topics are always the same, what you see here in terms of digital transformation, being flexible, being innovative and stuff like that. It is always on, but it moves across the dimensions over the years. And so if you look to the challenges which are as well short-term as long-term challenges, then we have always cost and efficiency on, you have competences on, and you have quality on. And if you talk today about functional safety and safety in general, then of course there is a quality attribute. So you see safety is highly demanded and is seen as a challenge on the short term and even on the long term. So it means our topic is, of course, on the top of the agenda of many companies. Okay, we are starting with some of the challenges and concept of functional safety and safety. We will have a look in the second chapter about our experiences. And before we do this, we will also summarize a bit the question and answers. So just to give you kind of preview that we have in the middle of the webinar, kind of summing up the most important questions have been answered so far. So we will share also some answers for those questions from those we think they are somehow interesting for many people. So 2, 3, 4 questions. So that will be in the middle of this webinar to let everybody know what's going on in the Q&A window. And of course, at the end, we will also provide a kind of outlook, kind of conclusion about safety topics we see currently in the industry. And we will give you some advices, some information about what are the upcoming next events on the vector side you should join in terms of getting more information about functional safety and also security, which is another upcoming topic, very close to the safety topic. Okay. Well, let's start with the basic challenges and concept of functional safety. So, of course, in the middle of everything, it's the car with this EE system. And if we talk about functional safety, then we talk about functions, features, you could call them, like electric power steering, electronic park brake, and maybe the airbag. And there are, of course, a lot more electronic systems in the car, or functions and features in the car, which are implemented by software and electronics. And that is the main focus, the main scope of functional safety. Why is it the main scope? Because concerning all these features and functions on the vehicle level, we need for, maybe for safety reasons, but sometimes also for comfort reasons, they could go wrong. The ISO says this is a malfunction, right? Something which is not intended on that level of function, kind of the airbag is unintentionally deployed, which is of course a heavy accident because it could kill people. So, and also that your electric power steering system suddenly steers in the wrong direction or is not supporting you by torque. So these are malfunctions which have a different effect on safetiness of the car. It could be a minor issue, could be a major one, but all of them have the potential, let's say, to harm or kill people who are in the car or around the car. So that all tying that together to one big picture means, okay, functional safety, and of course, even the standard which is written for that, the ISO 262, is caring for how we can avoid, of course, that malfunction in a ECU or on communication between ECUs. How can we avoid that a malfunction is occurring, right? And if it occurs, how we can mitigate the impact. All with the goal to save people's health and life. And that is about functional safety. So it is about electronics and software for sure, and it is about fault detection, which is then coming out on the vehicle level as a malfunction. That is a kind of essence of functional safety. So to avoid confusion, of course, yes, sometimes features and functions we are looking at from the functional safety point of view are even safety-related functions like the airbag or like automatic braking or something like that, which is safety-related function, which is also in the car to save people's life. But that is not the idea of functional safety, because there we look at if the function which should protect our lives, like the airbag, goes wrong, it could turn into the opposite and it's threatening our lives. So that is the point we are looking at from the functional safety point of view. Okay, so far so good. The next message, kind of more or less unhappy message, right? The functional safety is, of course, represented by the standard ISO 26232. That's, I think, is meanwhile known by more or less everybody. But the impact of that standard, the impact of functional safety to avoid all these malfunctions, that is a broad one. Unfortunately, it's not one method in just in software, or it's just one thing in testing or something like that. It is going across the whole recycle of engineering activities, but even management activities like project management or configuration management, requirements management. They are all more or less affected by functional safety. So we cannot exclude a portion of a process landscape, unfortunately. So if you, as a company, starting introducing functional safety, then you have to be aware that, or have to be clear that that is a life cycle impacting thing, and that brings in risks of having gaps there and inconsistencies. But of course, there's no way around to introduce functional safety if you are in the automobile industry, because that is meanwhile written in each and every requirement specification that if you have to deliver to first tier or to the OEM, then you have to fulfill the requirements of ISO 26232. That's a huge effort. That's not a minor thing you can introduce in the course of a project. You have to set up something like change management to introduce functional safety. Okay, that's some of the unhappy news for us, for guys who are responsible for the process side. More for the engineering side. So what is the next level of detail we are looking at in functional safety? So okay, we have understood the malfunctions, which is somehow here on the right side on the car level. So the idea of functional safety is that, of course, a malfunction is a more or less assumption. We just assume that something goes wrong in a ECU, which is controlling the airbag, or which is controlling the steering control, the braking system, whatever. So that is the assumption, but we don't know the reason behind. That is something, of course, we have to find out in the course of the development, and it's the chain of faults and failures you see here, right? So, of course, somehow on the left side, you can see a kind of code snippet represents the software. Maybe we have a fault in the software, an unseen, unfound fault so far. That fault cascades up as a failure to the next level. It could be the ECU level there. It is again a fault for the ECU level, cascades up to the level of the item or the ECU, and that cascades up maybe to a real physical function on the car level, which is the wrong function, again, a failure. And that failure, maybe not every fault in software occurs on that level, and not every failure on the vehicle level turns into a hazard. A hazard is really something we would call in normal language a kind of accident. So now we have bumped into a person, or we have hit the driver by the airbag or whatever. That is the hazard, and that, of course, what we want to avoid. So that means, yeah, we have to detect faults and failures by prevention measures, which could be a good process, could be a review, whatever. And we have to maybe also detect faults then on the product, right? If we cannot avoid that during the process or during the development time, that is heavily true for random faults, which cannot be avoided, that occur over time. So we have to have something even on board to detect faults, maybe to avoid them, or if we cannot avoid them, that is typically true for most faults, then you have to mitigate the effect. So that means the easiest case to switch off the ECU, which is typically called the item from safety point of view. So to bring it in a safe state so that it's simply doing nothing. And as long as we talk about ADAS system level 1 and 2 and other systems which are not on level 3 or 4 or 5, then of course just switching off something is typically good enough because the car can be still mechanically steered and braked and controlled. So if my whatever kind of system, let's take again the example of the airbag, or let's take the example of the automatic braking system or the adaptive cruise control or whatever, if we switch it off, it is good enough because still we can drive the car. So that is the idea of if you look down to the development of an item in the area of car EE systems, then it's all about the cascade of faults and failures up to the level of the car where it could turn out as a hazard. And that, of course, needs to be avoided by process measures and by measures on the product. That is all, of course, that is also important to lose a few words here. It is all about minimizing, reducing the level of risk below an acceptable level. So that is not the idea of having no faults nowhere in the car. That is simply not possible, especially in the area of the random faults. You cannot avoid it. You can just reduce the likelihood. And that means reducing the risk that something like a hazard occurs on an acceptable below an acceptable level. Okay. So we have talked already a few times about the standard behind all these things. So of course it's time now to show you how the standard ISO 26262 is structured. So you see here kind of top view on it. So each box you find here, gray and red, is a book. So a book about, I don't know, 50 to 70 pages, kind of average value. They have different sizes, but that's a kind of, as you have an idea how much lines of requirements we find in here. So that is what you see here in each box. You see, meanwhile, 12 boxes, so you can picture yourself that is a lot of stuff to be read and to be understood, a lot of requirements and recommendations, notes, explanations, whatever is in such a standard. So it's massive, of course, but the structure inside these 12 books should help you a bit better to focus on different topics. You see, the first book is just vocabulary where terms have been explained. Second is about the management of functional safety. The term safety management is maybe known. This is a kind of project management for safety. So the guy who's looking for all the work products you need for fulfilling the ideas of functional safety, that is the safety manager, and what he has to do is written in the safety in the book number 2, management of the functional safety. Then we have in the middle more the engineering related topics. You see it by the V cycles are shown there. We have the system V in the background, which is represented by part 3. That is about how do I get my my initial safety requirements, which are called safety goals. It's part 3. Then I have part 4. That's the system level. You can call it the ECU level. Development where hardware and software is still seen as one thing. And then you have to go down by separating your requirements along the V cycle down to hardware development, that's part 5, and software development, that's part 6. And then again, if you move up those sub-cycles, then you again meet hardware-software integration. That's the right part of part B. Now again, you are on part 4. Of the ISO standard, where you see all the test levels until you deliver your item to the vehicle level. And then you meet part 7, this production operation. That's somehow the idea, the middle part. And below you find in part 8, 9, and 10, you find the additional requirements for management processes, like I've mentioned already, requirements management and configuration management. That's part 8. Part 9, you find more or less explanations how to do safety analysis for software, hardware, and systems. This is kind of detailing out what is required in part 4, 5, and 6. Part 10 is no requirements. That is a guideline. So for guys who are starting with ISO 26262, it's strongly recommended to start with part 10. This is a guideline, explains everything what is written in the other books on a certain level of detail, of course, just to give people an understanding of the ideas and main concepts of the ISO standard. So you see also the red ones somehow here, the red boxes. That is just to highlight that since the beginning of last year, we have a new version of the ISO standard. Maybe that is also known meanwhile. That is the so-called 2nd edition or the 2018 edition, which came out at the very end of 2018, more or less. It was already 2019. And they added here and there, of course, a lot of notes and new explanations, better explanations for the correct understanding of the standard. That is across all the books. That's not shown here, but also 2 new parts came in. That is what we have highlighted here. That is a part 11. It's about, again, a kind of guideline for those guys who are manufacturing semiconductors for the automobile industry, like microcontrollers or highly integrated systems on a chip, because the hardware part in part 5 appeared as too classic, too much ECU related. So we need more information for those guys who are developing those complex systems on a chip, how function safety has to be implemented there. So they got a kind of additional guideline, which is more or less detailing out level 5 for semiconductors. So there are no new requirements in, but a better understanding how to understand part 5 in the scope of semiconductors. So there's one thing new, and the second thing new is the part 12. That is a kind of parallel book to part 3. So part 3 is for passenger cars and trucks, and all vehicles are in the scope of ISO 26262. Part 12 is a kind of adaptation of part 3 for motorcycles and lightweighted vehicles. So a special ASIL, we will come to that term later on, but maybe you know already that the ASIL term somehow is an important thing to express how much risk is in a certain function to threat people's life or health. That's the ASIL, somehow a kind of quality attribute. That is translated into the world of motorcycles and lightweighted vehicles in part 12, to also put these or draw these kind of vehicles into the scope of the ISO 26262. So if you're not in that business, of course, part 12 is not in your scope. So part 3 is good enough. And if you're not a semiconductor company, of course, then also part 11 is nothing you should be concerned about. Yeah, that is the ISO 26262. The first edition somehow plus big changes from the second edition. So in the essence, second edition is not a brand new thing. So the idea of functional safety and all the other books is the same as in first edition. We have here and there some additions and better explanations and hints and stuff to better understand what was written already in part 1. So don't get the message that second edition has fundamentally changed something. It is just improvement and enlargement of scope. Okay, you see also the purple thing here above. That is kind of pointer to there's even a new standard came up together somehow with the second edition that was just on the timeline. Of course, with the content side, it is something quite different. And I mentioned already the term SOTIF, and exactly that's a new standard which came out somehow in parallel to the second edition. That is the ISO 21448, which is called the safety of the intended functionality, and that is a short term and kind of abbreviation for that. It's SOTIF. Yeah, and the SOTIF is its own standard, and what that is about is also safety, but it has to be separated from functional safety. So give you a kind of short insight in what is the idea of SOTIF. In SOTIF, we stop talking about faults inside the car. We are looking to the outside of the car, to the environment, and we say, okay, unsafe behavior, to put it like this, could be also caused by hazards, finally. That's where we meet also the functional safety in that term, but the reason for that hazard could be also what they call functional insufficiencies and also foreseeable misuse by people. So what is that about? So of course, insufficiencies could be, for instance, I'm using a camera system on my car maybe for the adaptive cruise control, kind of traffic sign recognition, and I'm driving on my car towards the sunset. So the sunshine is starting blinding my camera, and I cannot detect anything. And so that means I have a kind of failure in my function, but it's not an internal failure, because sunset itself is not a failure, so we can avoid that. We can avoid driving on roads who are pointing in that direction. So that is not something I can avoid from the technical side. I have to live with that. So I have to at least detect this situation and do something in terms of informing the driver, switching off. That's again very similar to the functional safety, but the trigger for SOTIF is something like something happens in the outside of my car, which is somehow the car with the E-system cannot work with that. So it is, restricting my capabilities, so I have to do something, again, with the idea behind informing driver, he can still mechanically drive the car. He does not need to rely on the cameras, as long as we're talking about lower levels of automated driving. And there's also the other side, so somebody could have the idea to take his hands from the steering wheel while driving with adaptive cruise control, because it feels like automatic driving, but it's just keeping the distance between the fast driving car. So then something should happen, even again informing the driver, hey, please take your hands back to the steering wheel, because that is not a fully automated driving car, right? So be careful. That is a foreseeable misuse. And these things, somehow the driver himself is also part of the environment, is all seen as the scope of SOTIF. And to capture these things, SOTIF is using the terms of safe scenarios and unsafe scenarios, and they can be unknown or known. So out of these parameters, you can create 4 different kinds of areas. So kind of very big area, that's part area number 4, that's how they call it. That's the unknown safe scenarios. So there are lots of driving scenarios have been not considered during development. That is the unknown thing, not unknown necessarily by the driver, but unknown by the development part. So they are just safe. So hundreds and millions of things can happen to a car we have never thought about, but they are okay. They don't lead to unsafe scenarios. So the unknown safe. That's a good one, of course, right? We don't care about that. Then we have the known safe scenarios. Maybe we care about them in our requirements because they are known. Right? So that is something written somewhere, or at least tested somewhere. And as long as they are safe, they are also good, right? But then now we come to the evil part, that is the known unsafe. So that is a bit about we having already requirements about scenarios should be avoided. Maybe someone writes already down to avoid blinding of camera by sunset. Please measure the output of the camera, and if you have certain criteria like white areas on the screen, then inform the driver your camera is not showing you the right picture, so we have to switch off the feature. Please look yourself through the window, right, and do whatever you think is appropriate. So that is the known unsafe, right? That is already something bad. We should avoid it, but at least we know it by requirements. And the unknown part, yeah, that is the very bad part, because that is something, hey, we know there's something we have not thought about, but it leads to unsafe scenarios, whatever we have not seen, not thought about. And of course, the idea of the SOTIF standard is now somehow to reduce part 2 or area 2 and area 3, because it's the unsafe. It's somehow easy for the known. You can do that by verification. That's not so easy, but the unknown, that is something you have to cover by validation. But whatever you do, there are certain recommendations by ISO 21448. Not so many so far. It's not so strict as ISO, but the idea is, of course, we have to minimize parts 2 and 3 so that we get such a kind of picture. Somehow, again, we meet the idea of function safety to minimize, to reduce the risk down to acceptable level. We cannot avoid unknown, unsafe scenarios. That is, by definition, if they are unknown, we will have a part of unknown. We cannot reduce everything. We cannot minimize every unknown, unsafe scenario. And I hope you see the basic idea of SOTIF, how it is different to the functional safety. Yeah, and if you compare both in a kind of big picture, then safety is a kind of, we are making item boxes around ECU sensors and actuators in the car, and we look into these boxes and say, hey, if the fault occurs inside there, how we can avoid cascading to the outside. So we have to stop fault cascading to the vehicle level by whatever kind of means, process means, or on the car. To avoid that what they call a safety goal, that is the starting point of the essential requirements for safety. That's a safety goal. So we have to avoid that somebody gets harmed or killed. That is, of course, the idea of having safety goals. So the second thing is then, okay, something is on the outside, my sensor is blinded or is not looking in the right direction, or the angle of my sensor on the front has a too small detection angle, or whatever is the reason behind, could lead to some accidents or some unsafe scenario. And that is a limitation, more or less, of what we have designed, limitation of sensors, limitation of actuators, whatever. And that is the SOTIF part, right? That we think about that even during development time, if we have sufficiently good sensors or actuators and also computational power on the ECU, that we are reacting on certain events, the known scenarios, in time before we hurt somebody. So you see there's an overlapping in the goal, but the techniques and methods are quite different. Okay, so far about the SOTIF, was a kind of sidestep we have introduced here to the functional safety part. That is the main part, of course, but we think functional safety today can only be understood if you know the other side, which is upcoming, the SOTIF side. But maybe you got also the message between the lines that SOTIF is currently interesting if you talk about level 1 and 2, but the industry knows how to deal with that. Most of the measures we have to implement is more or less informing the driver if our EE system concerning sensors, actuators, or whatever is coming to its limits, then we have to inform and we switch off. So the engineering part behind is not so challenging currently, but in the future, if we have more and more level 2 plus, level 3, level 4, or even level 5 car functionality, then SOTIF is an upcoming challenge, because when we talk about methods, we don't know today, right? We don't apply today, and that's something we think about currently if we are in the area of highly automated cars, and exactly that is the question we are asking. For instance, how much we can simulate before we go on the road, how much scenarios we can simulate, because to cover all the unknown scenarios, that is a huge effort concerning testing, and that cannot be done with real cars. It would take too long, too many miles, so we have to find out other measures how we can cope with that. Yeah, that is the future part of SOTIF, so it's not the today situation. So that's the reason why SOTIF today is there, but it's not playing a big role in the area of concerns. That is still on the side of functional safety, because that is from the method side much more demanding. Okay, back to functional safety. Not to forget to say that it is just one standard in the automobile industry. It's not the only standard, of course. It represents a part of state-of-the-art of science and technology. But there are others. So, of course, all the known process standards like CMIS, of course, laws concerning homologation of cars. Of course, very basic standards like ISO 9001 and ISO TS 69949. These are all known and basic standards which are below ISO 26262 in terms of ISO functional safety is building on these standards, not kind of higher priority picture. It is a picture of how we how we stitch different level of process maturity together. And ISO is a kind of, can be seen, ISO 26262 can be seen as a higher level of maturity upon all these other known process standards. But it's not only process standard, it's also technology involved, right? So it is something I've mentioned already, that we have to do something even on the car. It's not just process during development time. And not to forget that, even ISO 26262 is basically not sufficient to represent the state-of-the-art of science and technology. If you are precise in that area, then you have to also name the research part, which is shown on conferences or written down on white papers and stuff. That is all part of science and technology. So that means for the legal aspect in the company, just to introduce ISO 26262, it would be a mandatory step, but it's not necessarily sufficient to do everything you can do to avoid liability issues. Right? That is more the message for the lawyers under us, but it's important to say that because safety is about avoiding harming people, so that is naturally the fact that we have to talk about liability. And the good news is ISO is helping us to do everything we need to do. It's covering many, many things from the state-of-the-art of science and technology point of view, but it's not everything, because technology and processes are evolving. So again, level of automation is one point. So the ISO standard cannot be on the top of all these developments. It's always a bit behind. So from liability point of view, we have to care also for things which are ongoing in our industry and shown and documented somewhere else. Okay. I mentioned already the ASIL. That is an important quality attribute in the functional safety area. What is behind basically the ASIL term? So the name is of course an abbreviation. It's Automotive Safety Integrity Level. Says something about the quality of implementation of a function that is meant by integrity. So how is that calculated, let's say, or defined? That is of course a risk value, which is always in quality. We talk about kind of risk measure, risk values in terms of how many faults are allowed for this function. You could express that by ppm or other quality metrics. That is not done here. ASIL is just an term or kind of enumeration of 4 stages. ASIL can be A, B, C, or D. That's it, right? There's no physical unit behind. But the idea behind is the higher I am in the ASIL, so A is the lowest value and D is the highest value. It means the higher you go in the range of the ASILs, less faults are allowed for this function. So that means on the other side, it is somehow critical. What does it mean? And that's expressed by the formula you see here above. It's, of course, again, the risk formula about the product out of severity and likelihood or probability. That is true for each kind of risk. It's always a product out of these both dimensions. And specifically for the ASIL, that means we look at potential impact of a malfunction. This is the severity, so how severe is that accident we see coming, as an average, of course. And the probability is subdivided in 3 parts. One part is the exposure, the PE, so how likely it is to be in a certain driving situation, being on a highway, driving by sunshine, no traffic around. It is a comparable, often seen situation in terms of likelihood. But driving on country roads, snowing and ice on the roads, and it's dark outside, no light, that appears a bit more seldom than the scenario we had before. So obviously there's whatever situation I have to consider for my function as being as causing a certain hazard and severity, there's a certain likelihood of that situation, of that driving situation. That is called exposure to a certain situation by the car or by the functions on the car. That is one thing, still it's likelihood, and there's a controllability, because still we have the driver in the car. Again, we are talking here even in functional safety about lower levels of automation, where we still have a driver who can react on something. And that is also a kind of measure of likelihood. So some situations can be easily handled, like one light, one head beam is switching off unintentionally. Still I have my second light, my second head beam on, so I can sufficiently see the environment. I can, maybe as a driver, can drive a bit slower. So that makes sense. So it can be handled, can be controlled. That is easy. But if my airbag just explodes in front of my face, so I cannot do anything. But you see, there's a different level of likelihood for these kinds of situations. So, and this is what we can see out of situations, driving situations we look at. So you see that somehow the approach behind is what we call the hazard analysis, that is going through typical scenarios the car and its functions could be in. And what is coming out is the PI. That's the likelihood of, I do allow that this happens, that malfunctions, to assure a kind of stable level of risk below acceptable level of risk. That is shown, or tolerated level of risk. That is somehow shown in the picture below. So whatever I do in my functions, it is an additional risk, and I have to do something on the car or in the process to reduce the level of risk below tolerated list. And PI is somehow giving me then the kind of measure what I can afford for certain functions considered the driving situation, to keep a certain level of risk. But we, of course, don't calculate with this formula, right? That is just to understand what is the ASIL. What we do is the RARA, I mentioned it already. This is looking like this. So on the left side, you see scenarios. Starts with the malfunction. Here we have the example of adaptive front steering, kind of steering support. So it can be no support. It can be steering is turning the wheels into the wrong direction. So I'm steering right, and the wheels are steering left, right? It can be oversteering, so steering too much according to my steering angle. and so on. So we have a certain number of malfunctions, and we put these malfunctions to different kinds of driving scenarios. So each malfunction typically goes through many driving or operational situations. That's the term used by ISO. So that is again what I mentioned already. It's a kind of driving scenario where you look at the speed of a car, what is the environment of the car, the highway, road, in the city, or during parking or whatever, and what are the weather conditions around. So that is all making up the operational situation, and then we do a kind of evaluation of those values we know already: exposure, controllability, and severity. They are evaluated by, again, 4 stages. So each dimension has its all 4-staged model, some definitions, and out of these determination of criteria by using a lookup table, we get the ASIL. That's the basic idea of what they call the RARA. RARA, again, is an abbreviation for the hazard analysis and risk assessment. That is a method that's shown here. That is a starting point of functional safety. Without having done that, you have no safety in your requirements, because behind here, we have not shown all columns. There should be also now a goal, the requirements tied to this ASIL. So the ASIL alone has no meaning. You have to tie that ASIL to a requirement. It's not shown here. Yeah, we can see it here on that table here above. So yeah, if you reduce the RARA to the essence, that you get a goal out of it, you get an ASIL for the goal, and you get a description of the safety goal, of course, in terms of we have to avoid that the airbag is inflating unintentionally above a certain speed or something like that. So it's a very general requirement, and we are starting from this requirement, going down. So item comes from the right side, then we have our RARA, and then we have done this, and we go down to the next level of requirements that is called functional safety requirements. They further detail out the very high level safety goal in certain separated requirements. These requirements are allocated then to an architecture, right? It is a functional safety concept where we have the software and hardware independent solution. And again, we refine this level down to what we call the technical safety requirements. Now we're talking about software and hardware. On the right side, we have again a detailed solution. From that side, this is the technical safety concept, and we have technical safety requirements. You'll see that the concept of system engineering is deeply embedded in the functional safety, doing the refinement of requirements on the left side and doing the refinement of solutions on the right side, according to certain levels of refinements which are defined by functional safety standard ISO 262. So that's the backbone of functional safety. Having your goals and your ASILs at the beginning, and then refining down the levels of development until you meet software and hardware, which comes immediately below the technical safety requirements level. Then we have then the software and hardware level where you implement everything. Yeah, important thing in functional safety is not just system engineering. It is heavily relying on system engineering. We'll talk about that. But there is more, of course, in addition, because we have to find faults and failures. That it cannot be just done by refinement of requirements and thinking about solutions. So one very obvious thing in functional safety is applying so-called safety analysis techniques, which are typically implemented as FMEAs and FTAs on system level, on hardware level, and even also on software level. So without going into too much details here, how FTA and FMEA works. So they are both different techniques, both have the same goal to find during development time, as soon as possible, potential root causes for faults and failures. The FMEA is doing that by the so-called inductive approach. So they starting by thinking about potential faults on the system level, maybe range exceeding of a sensor, or on software level or hardware level where we really have too high voltage or a shortcut or whatever. These are just things we are thinking about. We are not testing them. We are thinking about them, and we think also about our solution. What would happen to our solution? Would we find that fault? Would we react accordingly? Or would we affect the safety goal finally? That's the idea of both sides. FMEA is doing that with a one fault model. FDA is relying on a fault tree. That means even combinations of faults are considered. Typically in safety, that is not more than 2-point or dual-point faults. So we typically go not to higher levels of combinations. But in essence, that is the idea of a fault tree analysis. That they can do this. That is a very important addition to system engineering, let's say, to really fulfill the idea of functional safety, to find faults as soon as possible. That means during development. Yeah, if we tie everything together, it's all about faults and failures. We have different kinds of measures. You could easily separate them by some are in to find random failures, some are in to find systematic failures. So, of course, all the process-related measures, like safety analysis, like applying system engineering approaches, requirements, traceability, and stuff like that, these all are applied for finding systematic failures in our solutions. But you can also put measures on the product. It's a light gray area to find systematic failures by, for instance, applying self-tests or put in redundant functions which check what goes wrong on the product. Could also be a systematic software failure we have not found during development, which occurs in the field. And of course, we still have measures in place to find these failures. But for sure, we have also random failures. They can only be found during lifetime of the product. That means, again, we need to have so-called safety mechanisms which are doing some diagnostics on the product to find out what's going wrong. And in most cases, it means, okay, we have to switch off ourselves, go into a safe state. Yeah, that is a big picture. It goes across all the books of ISO, right? You see already by this picture, right? That is very different on system, hardware, and software level, and we need a lot of dedicated stuff on the process side and on the product side that cannot be written in a few lines of requirements. And so that makes the size of the ISO standard. And of course, this is all controlled or guided by the ASIL, because what we need to do, right? It's a lot of things we can do, but of course, not everything makes sense in terms of ASIL. So how risky is that function, right? How likely we can harm somebody? That of course plays a role in terms of how much process effort we have to spend and how much effort we spend on the product side. So that is the essential idea of the ASIL, to give guidance there by the standard. Okay, that is the first part of this webinar. So the second part will be not as long as the first part, so don't be concerned. But it's time, because we went through a few important challenges and topics of functional safety and SOTIF. Maybe I see it already by looking at the QA window. There have been a few questions, so it's time to switch to Andreas, that he provides some top-level questions and their answers, of course, we have seen so far.
Yeah, thank you, Arnold, for this presentation. I will try to keep it very short, because we are all looking forward that you share with us the experience we have made over the last years. Yeah, there were some questions around, and I'm still answering most of them. Some were dealing with the scope of ISO, and so what is really covered by the standard, and except for the vehicles and stuff like this, so passenger cars, trucks, buses, and so on. What is really in scope? So it's the development of EE systems, which are building up what is called the item. The item is defined as a system or array of systems that realizes a function on vehicle level. And this system consists of hardware and software, basically, and you find them in sensors, controllers, and actuators. So topics like mechanical are out of scope. And then there were also questions about SOTIF, if SOTIF is applicable for all safety functions of a car. I think you made this also clear in the presentation. SOTIF is something on top. As soon as you develop a safety-related function, you also should consider SOTIF. It is mainly located in the area of driving assistance systems, so where you have this direct impact of technical insufficiencies on the safety of the driver. Yeah, and there are still more questions coming in, so I will get back to the Q&A so far from my side.
Yeah, I hope you can hear me again. That is what I hope. Okay, yeah, thank you, Andreas, for that summing up most important questions, right? And of course, all your individual questions still will be answered, right? We will not stop doing that. Yeah, yeah, I would say we can go ahead with the planned stuff about best practices, or kind of our experiences, right? So what we have heard so far, it was more about what really is essence of the ISO 26262 and the SOTIF standard. Again, that is not so demanding currently. If you look into it in terms of required methods, that is not comparable to what we find in the ISO 26262, right? That is because of the number of books and requirements, so many things are in there. The functional safety part is much better understood, let's say, by our industry. So we have a much clearer understanding what we need to do there. So that makes the demand of functional safety. I would not say functional safety is somehow more important than SOTIF, but currently we have a very clear understanding what we expect there, very detailed understanding. And so it makes sense to look at our experiences, how we implement functional safety. SOTIF is something we see upcoming at the horizon. Today, yeah, we have understood the terms and the concepts, but the daily practice is not so much impacted by that. But we will see, because it's a very soon and a kind of early publication of an upcoming standard. So we will see that upcoming more and more in the next years, and it will have a stronger impact on our business than functional safety has it now, right? But that's for the future, depends on what we implement on the car. So expecting and assuming that we have more and more automated functions, that's going to be a more demanding thing. That's a kind of situation we are in now. Functional safety more demanding, but much better understood, let's say. Currently, SOTIF we see upcoming, but currently based on what we have in our product, the car itself, it's not so impacting our daily business, but that is going to change in future. Okay, last part of this webinar, right, to give you short insight into how we are approaching things in terms of implementing ISO 26262. The first things I mentioned in the beginning, functional safety is impacting all the phases in our development process. So we need something that ties together, which is typically the safety plan and also the DIA. These are both instruments from the management part we use to tie our activities together in terms of work products. So that's the good thing in ISO. Every requirement is tied to a kind of logical work product. So we have to provide our implementation of these logical work products, and then we implement all the requirements of ISO. But these needs to be tied together in a document, safety plan. If we have suppliers, we need a DIA to align with them, the safety life cycle in the middle. Or we use tools for that to help us to keep all these informations together. Like Provision is such a tool from the vector side is doing this, but then also other tools doing that. So that is more a question of what tool we use. The idea is the same. Yeah, even this is the best practice of what we do concerning safety analysis in software, because that is an unknown part. For unknown, let's say, in the area of general software development. So in hardware and system, we use these techniques even outside, say, functional safety. But for software, safety analysis is not really known, because traditional software development goes more in direction to early test things and to continuously deploy or continuously integrate. So to do safety analysis on the software architecture, it is a bit unknown. So the techniques here are not so obvious. So that is the reason why we show you here one instantiation, how you can do that. So the so-called SW.FMEA could be applied here. That is essentially the same thing as in FMEA on system level, but just applied to a software architecture. And what we do here is a kind of trick that we replace occurrence, which is not there in software because we just look at systematic faults. We replace that with complexity terms for software. So the idea behind is the more complex the software component is, and more states, more lines of code, more cycles, maybe complexity metrics can help here, right? That is not so important as long as we have a kind of metric here that we replace occurrence of a random fault by a complexity of a component, which leads to the idea the more complex the component is designed, the more likely it contains a fault, right? That is the idea here. And so with that idea in mind, you have to be a bit used to it after a while, but after a while you can just use FMEA like on every other level of development. So it works for software. It's a bit cumbersome because you have to trick out the FMEA idea, but it works on software level. That is one of the very practical ideas we recommend to fulfill the requirement you have to apply a software safety analysis. Even that is already said. ISO 26262 functional safety is about requirements and architectures. So it's a two-pillar approach behind, which is part of the system engineering approach. So you have requirements and you have to assign requirements to your solutions on different levels. So that drives heavily the modeling techniques. So very obvious and prominent is the SysML on system level and even the UML on software level. These techniques are driven by ISO, not just by the two-pillar approach. You could also still describe your solution in another way, but latest on software level, it's a requirement to use so-called semi-formal notations. That means modeling techniques. So in software, it would be the UML, and along with that, we see it more and more coming in each and every development project that the SysML is used on the system level as a modeling technique, and that is also still a notation which is semi-formal. It is more recommended, not required by ISO, but ISO is there a bit conservative. We would recommend to use these techniques on system and software level on the solution side, and then requirements then are assigned by this, and that leads to the ADAS you see, for instance, here, which are put on the component that is a consequence of having safety-related requirements allocated to certain components in your architecture. Yeah, I mentioned already DIA. That is another famous instrument in safety. So that is how it could look like, more or less. It's a RASIC chart. We have on the left side all the logical work products from the ISO. In the middle, we have that is provided by the customer, let's say in this case, the OEM. So he's saying, okay, I provide you maybe the safety goals, I provide you the function safety concept, and that's how we treat them, how we review them. It's in the middle, and you provide me the next lines here below, next rows. You provide me the refined, I don't know, software architecture design and the design, the verification plan, and so on, so on, so on. That is on your side, and also this is then determine how we deal with that. That's a DIA to show again the safety life cycle from both sides so that we don't miss anything. That's the idea. The DIA, because we have both companies have their own safety life cycle, but they have to bring into alignment by this DIA, because not necessarily everything it's provided is sufficiently expected on the other side, and vice versa. Yeah, kind of last words, which is, I mentioned it in the beginning already. Yes, this webinar is about safety in SOTIF and functional safety in SOTIF, so it's about safety, let's say, but we see it more and more coming now, and currently in this year we see it really in projects, not just on conferences or just for public publications. We see it already in the project that safety is heavily impacted by security. So along with the RARA, let's say, which is the top level start of functional safety, you get more and more the so-called threats and risk assessment, the TARA, which is also creating requirements which are called then security goals, right? So you see terms are very similar, but by intention or by accident. So you see the concept of security in the car is very close to the concept of functional safety. Of course, the contents of requirements, and of course, some of the methods are different. It's not all the same, but it's very closely aligned with the system engineering approach of functional safety. So if you are in safety, you will certainly meet, of course, if your item is affected by security, you will certainly meet now in the new projects which are upcoming cybersecurity. And that is covered by a standard ISO SAE 21434. So another number of ISO standard is coming up. It's meanwhile in the last phase of being published. So it's not published, it's not out, but still the plan is, we will see, that in the end of this year we will have the standard out. But as a kind of forecast, we see, because Vector is involved in the definition of that process, what we see now in the standard is very close to safety. Some terms sound very similar, like security codes, RARA, security concept. You see, there's all terms we will easily map to the safety side, and that is intention, because the expectation is that we want to develop our ECUs and items according to safety and security in the same system engineering approach, maybe different views and different work products, but it's the same approach behind. And so it will be, the engineers will meet who are doing security and doing safety, because they have to have an interface, because it's also obvious, because if you have a security issue, it could impact safety and vice versa. Right? We cannot do that independently from each other. Yeah, that's the new stuff we see coming. That's very close now that I would expect that even some of you already have seen something in your project. If they have started maybe somewhere end of last year or beginning this year, then you are already in the security scope, because more and more requirement specs from the OEMs containing already references to security standards. But that is another topic, and we have also webinars for that. So if you look at the Vector Consulting YouTube channel, for instance, or other webinars which are upcoming, then you will see that. That brings me to the conclusion and outlook. So yeah, functional safety is still growing, but also the majority of OEMs and even tier ones have already written the contracts, also have introduced it to their processes, to be honest. Lots of software and hardware components according ASIL, whatever, are available. So we are out of that beginning phase of ISO 26262. Most companies have processes and components and products already on the market. But we have still new suppliers coming in the automotive market. So I am not used to ISO 26262. That is something in terms of a gap we still see there. We still have efficiency issues, so not everything is done. In the early days concerning processes at the company side has been a smart solution concerning efficiency. We have a lot of administration and bureaucracy in the standards, in the processes, so there is still work to be done. And we have, more and more security coming in. Again, leads to some new improvement cycles on the development process side. Yeah, of course, as a Vector, we provide you solutions. We provide solutions on software and hardware side and tool side, embedded software side like AutoSAR, but also we provide what we do on this consulting service side, engineering and consulting services for safety and for security. Yeah, last words to what is upcoming. I mentioned already, yes, we have more webinars, you find them here below, about security. We will have a new one at the end of May. I will invite you to this, because it is about, if you are a safety expert and you want to dig into the security, then you should start with this one. So not starting with pure cybersecurity, start with the kind of combination out of what does cybersecurity mean for safety experts. And that's going to be provided on the Automotive Cybersecurity for Safety Experts webinar on the 27th of May this month. So if you like to know more about that, I would recommend that to every safety expert. So join us there. But we have also more stuff in terms of white papers and virtual trainings. We have also, of course, more webinars recorded out there you can find in YouTube. And of course, we will have our Vector Forum in June. That is still planned. It was planned as a real conference on site at Vector, but because of the Corona restrictions, we have to conduct that one as a virtual event. It will still be the planned event, but just the presentations will be online and virtual, not physical on-site Vector. So you also invited to that event. So that's all from my side. Again, for everybody who has launched a question, stay tuned if you can. You get an answer now in the Q&A window by Andreas. If you have no time, that's okay, of course. We will send you the answer by email within the next few days. So again, every question is going to be answered. And thank you for staying tuned so long time. Stay healthy and hope to see you soon.